So I want to welcome everyone for coming here to Beltsville for this high-throughput phenotyping and data analytics meeting. And I want to start off by thanking a lot of individuals so we don't miss this opportunity because of the work in which they have put into doing this. So the first was an actual ag library itself for the venue in which we're in, for so kindly hosting us here for the next day and a half. And then USDA ARS individuals that are here somewhere. Janice, who's back in the corner, has been instrumental in terms of helping everything. Is Lauren still driving people? She just pulled up, okay. And then Kimberly, who has also helped with slides and stuff, and Carrad, who's back in back. And Carrad needs a great shout out to him for everything in which he's done, both for this meeting and then the meeting that will follow this as well. So thank you very much, Carrad. And then the funding that Lakshmi, back probably in January or earlier, wanted us to try and put the meeting together, and we said sure. And then we all got busy with Guilherme, and eventually we did get it put together in order to fund this meeting. And it's with their thankful funding for this that all of this is possible. And then also we need to thank the organizing committee, which unfortunately is not all here yet. James Coltis and Nick Sarau had plane troubles yesterday, and they won't be arriving until probably about 10:30 this morning, when a flight will arrive actually from Kansas City, that they had to drive a little extra. And then Raluca Matescu and Guilherme Rosa for helping as well. They very much need thanks for their work. So why are we here? What is it that we hope to accomplish? So hopefully we can discuss more state-of-the-art for both high-throughput phenotyping as well as the data analytics associated with. And for high-throughput phenotyping, I want you to think in very broad terms, not just simply probably at the animal level, but probably all the way down to the cellular level and everything in between. What is it that we should measure? Why should we measure it? How can we measure it? Are there new technologies that we need to develop in terms of sensors or other things to allow us to very cheaply do this? And then, once we have all of this data, how are we going to make sense of it? How are we going to turn it into useful knowledge that could, in terms of livestock, be applied to the industry to do something that today we could not possibly do? Could we identify every animal that is going to that is sick at a point prior to any human eye ever understanding that it was sick? But what are those sensors that we need to do that? Could we do it all with a camera? Do we have to have some implanted device? Could we do so for pennies on the animal in terms of doing it? If we could do that, we could have phenomenal change. But unless we can process all of that data in real time and probably have it show up on someone's cell phone and find that animal in an easy way, are we fully going to be able to utilize that information? So please think very broadly in those contexts. For the most part, in my own brain, this is pretty much species agnostic, with the exception of what we probably implement in the form of poultry may be different than what we would put on a cow, because they're different sized animals, they have different things in which we'd measure. But again, I think it has applications for every species. It's also hopefully going to be discipline agnostic, that I could easily envision a system in which you could set up to optimize nitrogen or protein being provided to the animal in its diet in order to optimize the growth of that individual animal for doing stuff, as well as the genetic applications that would be there, or better understanding physiology or the health of the animal itself. So please think very broadly in those terms as well. Also, can we identify then those opportunities, those knowledge gaps? What are the things in which, as a group of researchers, we need to work on in order to close, such that we can take where we are today, what is the state of the art today, and move it to something that may not be realized for 10 years or 20 years in terms of doing it. But what are those pieces that are so very critical in terms of trying to implement this? Some of this, we could determine that it is access to high-speed internet in very remote places in the United States, where we have large feedlots that may not have the ability to do this, but if they could set up something locally, maybe they could utilize things to a greater extent. And can we articulate then that vision for the future? And our desire, at least from the organizers, is could we then write a white paper in order to help quantify this and get it out into the general research community and say these are the things that we think are priorities within this area for folks to work on across the species. So to help us go forward in terms of doing this, we have a number of different speakers, and I'll go through the first couple just to give a little background. The first is Natalia de Leon, who's going to talk completely outside of animal agriculture and say more of what's happening on the Genomes to Fields project, which is massive in its scope. And I hope that we can actually use it to some extent as a model to say what is possible on the livestock side. Because if we look at the land-grant institutions across the United States, almost all of us have animal populations, cattle, pigs, chickens, sheep, goats, but we do everything individually for all intents and purposes. Is there an opportunity in terms of, say, beef cattle, that we could bring 10,000 head across the United States together, being phenotyped in a common way in order to answer questions across all of the different disciplines of animal science? To some extent, the Genomes to Fields project lays out a way in which, at least on the corn side, that they're attempting to try to do that. And Natalie will talk more about that. Santiago will tell us a little bit about what is happening on the poultry side as a genomics company, how they're trying to utilize high-throughput phenotyping in order to move genetic selection forward on the poultry side. Then Victor is going to tell us more about the things in which they're doing for modeling and optimization and high-throughput performance computing and everything else at Wisconsin, which are leading a large project there. And then Raluca Matescu is also going to talk about utilization of technologies in order to look at heat stress in beef cattle. And hopefully these talks that we have this morning, this afternoon, and then tomorrow morning will help give us a framework of what is possible out there in some of the different areas in terms of collecting phenotype and then physically processing it from there. With that, I think I'll welcome Natalia up here in order to get started.